Okay, so we're back from break. Let's go ahead and talk a little bit about objects and classes. Let me switch on over to the PowerPoint. And so again, what we're getting into now is what we've done before is taught you how to write basic sequential programming of how to use control structures to make things happen, how to have methods that we can call, that we can pass parameters or arguments to a method. We can get return values, or we can have a method that does something. But that's not all that programming languages can do now. Like, when I was your age and I was learning, I learned C. C was my first higher level language that I learned. And C is not object oriented. And so all we could do back then really was some of the sequential style programming that you've learned last semester. But there's certain things we might want to do that would be able to that would be more useful in an object-oriented style. And what we'll talk about is, like, so example here with this, like, UI, we might want to say show some graphic user interface, and we might want to have some information that all kind of goes together, right? So we want to have a student's name, some other information about it, what classification is this student. We might want to have all this information kind of related together and kind of flows together. But notice that they're different types. So, like, if we were to say, hey, we want to represent a student and we want you to be that student, there's like lots of information for you that goes along together. Your name, your student number, your birth date, what else? Your classification, your hometown, your phone number, your email address. And these are all things that are different data types that we might want to make sure they go together. Towards the end of last semester, there was not the last assignment, but the third assignment. The third assignment required you to kind of create a list of arrays, right? Where you had different products and prices. Right, we did the no, is that right? Yeah. Where what we did was you created a list of arrays, like a lot of arrays for the different data types that kind of go together, right? It was grades. Okay, so last semester was the grades listing. Okay, I'm thinking of the semester before that. Sometimes I get these confused. Right, but you had names, you had a names array, you had a scores array, you had a this array, you had that array, right? And you kind of had like a bunch of different arrays, and you use the index value to determine use the index value to determine which student it was, but you had to go to that index in the student or in the name array, and then you had to go there in the grade array, and so forth, and like that, right? But what if we had instead, you just had a student object, you had a student thing, and that student thing had within it an attribute for name, and had within it an attribute for grade, and an attribute within it that was something else, and all these different things, right? So then you could just have that one item, that one thing that would have all this information, and it would go together. Okay, so that's what we're getting into with this whole idea of object-oriented programming. Okay, an object represents some kind of real-world entity that can be identified. A student, a desk. One example we'll keep coming back to over and over again will be the circle, shape, a type, a geometric shape, right? A bank account. A bank account can be an object, right? So we can have different attributes, properties, data fields, whatever you want to call them, that the object can have, and they can also have methods inside. Okay, The truth is you've already been working with objects. You just maybe didn't know it. The objects that you have been working with already are strings. The string data type in Java is an object, right? And so it comes along with data fields and behavior in the form of methods. Remember the length method on a string tells you how long a string is, right? Well, that's a method that's a part of the string object, that's part of the string class. Okay, so if we look how to represent an object, as we might say, okay, it has a data field. So a circle, you guys know what a circle is. It's represented as a geometric shape where every point is the same distance from some center point, right? And every point on the circle is the same distance away from that center point. And that distance, the distance away from the center, is what we call the radius, right? So every point on a circle is whatever the radius is distance away from a central point, you know, in a plane. Okay. So the only data that we need to know to make a circle is what is the radius. We don't need to know anything else to make a circle besides what's the distance from the center point. Once we know that, we can make the circle, right? But there may be a method, like something like a method, that would be the get area method. Right? And so area isn't necessarily really a property, right? An attribute of the circle. Area is the amount of space that the circle contains. So really the only information that we need to know for a circle is the radius, but using the radius, we can find out what the area is. We can find out what the circumference is. We can find out what the diameter is. There's all kinds of things that we can find out from a circle with just that one piece of data, right? That one value. Okay. So we can have multiple different types. So note, this is the template. This would be a class, and then an instance of that class would be called an object. Okay, so I need you to make sure that you know the difference between the class, which is like the blueprint, right? It defines what some of those things are, what the things we're going to keep track of, what attributes, properties are we going to track or are we going to have. What are the methods? What's the behavior? And that's where that's defined. The object is a instance of that class. So let's say I drew a bicycle out on paper. That would be like the class for a bicycle. Is it saying this is what my bicycle should look like? My friend can take that drawing and make bicycles, right? He can actually make real world bicycles. And then those individual bicycles themselves would be the object. Okay, so the thing on the paper that defines how it's going to look, how it's going to act, that's the class. The actual thing itself is the object. Okay, so make sure you know the difference. The class tells you what it's going to be like. The object is actually the thing itself. So we use classes to define the objects of the same type. Right? There's some special methods we'll talk about called constructors that we will use to make objects of that class type. So an example of a circle class might look like this. Okay. So here we have a class, call it whatever. All right, circle in this case. We might have some data fields, so we can also call them properties or attributes, variables. Okay, any of those names work for this, right? So we'll have a radius. Now, this variable, this data field, can be used inside of our class anywhere. Okay, it can't be used outside of our class, but it can be used inside of our class. And there's another word for those of you who have had this course before. You will note that there's something missing here. We'll talk about what that is. There's a what's called a visibility modifier that we did not include in this example. We'll get there. All right. So We have a radius. This is its name. Its type is double. We can give it an initial value. That means that when a circle is created, if we don't set the radius value, it just automatically creates a circle of radius 1. Okay. There's some constructors. We'll talk about what these do. 2 different possible constructors. And then we'll have a method called the getArea method that calculates the area based on the radius and returns that value. Okay, so if we think about it in the string class, remember the string class had lots of methods like length or char@, right? And so when you call a method in the string class, it does some type of calculation. So the length method somehow calculates how long a string is and returns that value. The char@ method goes to that position in the string, that index of the string, and returns that character. Okay. So we're going to definitely be learning a lot about UML this semester. So this would be an example of a UML class diagram for circle, okay, for the circle class. Now notice that it has a class name in the top section. It has any data fields in the second section. And in the last, it has any type of constructors or methods. All the methods would be listed here. Now, usually we might not include a constructor, what's called a no argument constructor. We'll talk about what a no argument constructor is here later. We might not always include that one there because it's a given that it should be there. Yeah, we do any special constructor and any methods that we create need to be included in here. Okay. Now, notice for the UML object notation is a little bit different. It's also still a box, but now we have this underline and we have its own name. Okay, so remember, this is the class name. This here is like the variable name. Okay, what we're calling our circle, followed by a colon, followed by what is its class type. So if we saw this, we'd say, okay, circle 1, right? What kinds of things does circle 1 have? Well, we can look through the circle 1 class diagram and say, okay, it's a circle. So we know that it has a radius. We know that it has constructors. We know that it has a getArea method. Okay. Notice that this diagram, a class diagram, doesn't tell you anything about what's inside of the getArea method. It only tells you that there is a getArea method, and it tells you what it returns, what data type it returns. Okay, so it tells you there is a getArea method that returns a double. It doesn't tell you what's inside of that method. That's a different diagram type in UML. That's what we'll call an activity diagram. We will talk about that this semester. It's like a flow chart. If you can remember as far back as last semester when we talked about flow charts, that's what an activity diagram would be. So a class diagram is used to show the structure of a class, not the behavior of a class. Okay. And as we'll see later in the semester, the class diagram is also used to show how different classes are related to each other. So for example, we might have a class for, what is it? Might have a class for like a university. We might have like a system for a university. And you might have a student class. You might also have a course class. And what you would want to do is you'd have a relationship between the two, right? That students take courses and courses have students, right? So there would be a relationship there. And we'll get into how that works later in the semester. Okay. So we'll show this example in just a moment. I do want to go ahead and show you kind of how this is going to work with the examples and stuff like that. There's a simple circle example that we'll get into. Okay. I want to talk about constructors because the constructors are a special kind of method. And what they do is they create the object and they give us that object type. All right. Constructors can have parameters and they can have no parameters. Notice there is no return type given. It's not like double circle or int circle or string circle or anything like that. The reason why is because this is a very special method and its only job is to create an object of whatever the class type is and return that object. Okay. So it's not going to have a return type. Okay. A couple of notes. All right, for constructors, if we have a constructor that has no parameters to it, no arguments, we call that a no-arg constructor. Constructors must have the same name as the class itself. So if we have a constructor for circle, but the name of the class is something else, and remember, capitalization is important. So a capital C and all other lowercase letters. That means the class name must be called that. Now, one thing I do want to point out, that does not mean that the file name has to be that also. Okay, this is where we might get you a little bit confused. But one thing I want to make sure you guys remember is that the file name for a Java program must have the same name as the public class in that file. But the file can have more than one class in it. Okay, so we could have like a class called, we could have a class called circle inside of a file called geometric shapes. But we need a public class inside of that file called geometric shapes. Maybe I'll show you that as an example here in a moment. Okay, but I do want to finish off our discussion on constructors, do some examples, and then let you guys go because it is the first week, and I don't want to take up all the time because I know that you guys are probably still a little tired from the break. Okay, all right. Again, constructors don't have a return type. They're not even void. There is no return type given, and constructors are invoked. We use them using the new operator. And so we'll say circle C equals new circle. Okay, we use constructors to create the objects, to initialize them, to do anything that involved in the creation of the object itself. All right. So the new class name creates whatever the class is. So example, new circle would create a circle. In this example, based on what we looked at before, this would create a circle of radius 1. And the reason why was because the default value for radius was 1.0. Here in the second example, we're creating a circle of radius 5. We are not required to write our own constructor. If we do not write our own constructor, the class must have a constructor, so a hidden no-R constructor is there. So if we don't have any constructors explicitly defined, all right, if we don't have any constructors written, then Java will create a no-R constructor that does nothing. It just creates the object and returns the object. That's it. Okay. If we define a constructor, however, we lose the no argument constructor. The no argument constructor does not exist. Okay. A couple of final points on this. Just like variable definitions, when we talked about creating integers or strings or doubles, right? If we want to create a variable to hold our object, we can do that we just have to tell it what type it is. So circle, my circle creates a variable to hold the my circle, the variable called my circle that holds a circle object. So something like this. So here we're saying circle, my circle equals new circle. Okay. What happens here, and I'm going to show this in using the whiteboard, using the Microsoft whiteboard in just a moment. What happens is we have a variable called my circle that we can have it point to an object of the circle type. Then here on this side, we're creating a new circle object. And what we're saying is we want to point my circle to that object. Okay. So I'm going to do that on the whiteboard. I'm going to show you that because I think I would, if we were in the classroom environment right now, I would show this on the whiteboard. So what I'm going to do is do that. Share whiteboard. There you go. Okay. All right. So here, and there's no way to type, is there? Is there a way to type on this thing? Oh, there it is. Okay. All right. So here we have circle. I'll just call it C1 actually equals new circle, and we'll say 5.0. We'll create a circle C2, so we can see two possibilities here. Okay, it's kind of weird. Okay, so if you can see that this is what we're going to do. Okay, this is our 2 lines of code that we're kind of going to see what happens when this occurs. Okay, so the first thing is we're saying, okay, we want to create a variable called C1. Now remember what happens when we do that, right? We have this thing in memory. We'll call it C1, right? Now, what our code is saying is it's going to be able to hold something of this thing called a circle, right? Okay. Need to get a pen and a touch screen on this, right? Let's see. Can it be bigger? Oh. No, that's color. I don't want color. Is there a way to make it bigger? I'm not used to. Oh, there we go. Wait. Okay. Does that work? How better? Okay. So this C1 and now my pen kind of messed up over here. So we're creating this circle C1. So we're saying we're going to create this variable called circle. Now then, let me change color so you can see what happens here. This side, what it's going to do is it's going to say, okay, out here in memory, remember this big memory stuff over here? In some address, we're going to have this circle object with a radius of 5, right? And we'll give it some address, you know, 1000, for example. Right. And then this equal sign, this is nice with this multiple different colors here. All right, with this equal sign, what it does is it simply says, put that address in there, into that variable, so that it now points to that object in memory. Okay. So now when I access C1, just like if I were to access an integer variable or a string variable, I'm going to get access to whatever that thing is in memory. Okay. So in the same way, if we do, oh, that's not what I'm going to do. I'm going to do blue. All right, C2, which is also a circle. All right. And it creates, on this side, we'll call it 1004, some circle object. Now its radius, because there is no parameter passed, its radius is going to be 1. Okay. And what the equal sign does here is it says, okay, we're going to put 4. I'm going to put 1004 so that it points to this now. And the reason why I wanted to go through this is because what happens if then you do C1 equals C2? Okay. Now this is a question I want to ask you is, what do you think is going to happen if we do this? Okay. I think some of you guys are getting there, right? So I think some of you guys are getting it, right? So here's what's going to happen is we would think, what we think should happen is that C1, its radius should just change. We think that this should now become 1 instead, but that's not right. That's not what's going to happen, right? What's going to happen here is that C1 will lose this value and instead will become 1004. Okay, and I know this is kind of hard to see and I'm sorry about that, but then what that means is I can erase this. This no longer points there, but now instead points there. And I'm thinking one of you at least in the class right now is thinking to yourself, okay, now we have 2 variables that point to this 1004 address, but one of you's thinking, well, but what happens to this? Nothing points to it anymore. What's going to happen? Right, Osgore, you've been looking ahead, right? So there's a lost connection. It's still there in memory, but we can't get to it anymore. Exactly, Budak. We cannot get to it anymore. And when we talk about garbage collection, this will come up. Because what I want to make a point about here is, I'm sure some of you have heard the old saying, you know, oh, if the computer's running slow, just have you tried turning it off and turning it back on again? Right? I'm sure, you know, some of you have probably, you know, said that to your mom or your dad or a friend who said, my computer's running so slow, right? And what can I do? And you say, have you tried turning it off and back on again? And the reason why we give that as an option, it has to do with this right here, okay? Because in a running program, where this is happening is in this section that we call RAM, okay? Random access memory. It's fast memory. It's the thing that is the smaller number. So if you buy a computer and you have a an 8 gigabytes memory, but a 500 gigabyte hard drive, the 8 gigabytes is RAM. Okay. Now, what would happen is in early computing and even up till not too long ago is we would fill out this, we would store this stuff out in this memory location. It would be reserved for our program. And then at some point, the program would stop needing it. It would stop using it for whatever reason. But it would still hold on to that memory location and no other program could use it. Right? And then what would happen is as it used up memory for this, then it used up memory for this, then it's for this, then for this, then for this, is it would start using it all up, and then new programs would have to try to find available memory, would try to find available RAM. And it couldn't. It would have a hard time finding available RAM because all these other programs were using it up, even though they weren't using the variables anymore, even though they weren't using that data anymore. And so the computer would start to get really slow because it would be spending a lot of time trying to find available memory to use. But if you say, okay, well, you know what, I'm going to turn the computer off and back on. RAM is something we call volatile memory, meaning that when the power goes out to the RAM, all the data gets lost. Okay. And so what would happen is you would turn the computer off, it would clean all this out, you would turn the computer back on, and guess what? All your RAM is now clean. There's nothing there anymore. There's lots of available memory for that program that you wanted to run. And so that's why your computer would start running faster now, is because now there would be lots of available memory to use. Okay. But what some of you have been mentioning here is the whole garbage collection or garbage collector. Java, one of the things it does is if it notices that there's this thing in memory out here, a circle, a string, or whatever, and it's not being used by any program anymore, it automatically says that memory is now available to be used by another program. So it collects that garbage. It collects that unused memory location and says, hey, we can use that somewhere else now. Okay. One of you did ask a question about why is the C2's radius 1? Nisa Julia, you asked that. The reason why is because if you go back to the slides, you'll see that the radius, when it's declared, the double radius equals 1.0, that's the default value. So if we don't give it in the circle example, if we don't give it a value here, it gets a default value, an automatic value. Okay, so that's why that's there. Right. In fact, let's look at that. Let's look at good question. Okay, good question, Dijle. So she's saying, what happens if instead of this, what happens if instead of C1 equals C2, we did C2 equals C1? Okay. Well, in the same way, what would happen is the C1 value would be put into here instead. So if we did it like this, then what would happen is 1000 would get copied into here. And so they would both point to this circle instead. Okay. All right. All right, so let's actually look at, let me go ahead and pull up. So I'm going to use all three. I'm going to use the slides. I'm going to use the whiteboard, and I'm going to use JGrasp all in the same lecture. That's hopefully going to be a normal thing. Hopefully that'll be what we normally do. All right, let's see, JGrasp, here we go. All right, let me change the font so that it's bigger. Okay. And we're going to look at this test simple circle. Okay. So notice that the Java file has to be the same name as the public class. Okay. Make sure you guys remember that. That's important. Okay. But also notice that there is a non-public class. There's just a class called Simple Circle that is inside of the same file. Okay. This does not have the same name as the Java file. Whatever is the public class name needs to be the Java file name. All right, Java file, public class, same. Simple Circle class, that's fine. Notice its constructor has to be the same as the class name. Okay, so Simple Circle, we have a constructor with no arguments, creates it of radius 1. Notice this is the same thing as if we had done this. Not minus. Right, equals 1. Radius equals 1. Constructor with no arguments. That's fine. Right. We can do this either way. This is a good example of two ways of doing the same thing. Okay. These two would both operate the exact same way. Simple Circle, we can give it a radius value where we say radius equals new radius. Notice that this variable and this variable have to be named differently, right? There's a few different ways to do this. Some of you may have seen something like this. Yes, radius with the this keyword. Okay, that's also a way that we can do this. Okay, that way these two are the same, and this is telling us I don't want the variable named radius. I want the thing inside of this class called radius, the variable inside of this class called radius. Okay, two different ways again, same thing. However you want to do it is fine. We'll talk about the perimeter. Yeah. Okay. So we have the area, we have the perimeter. Right. We will talk about this whole idea of the getters and the setters this semester. We'll talk about that later. Okay. But notice that what we're doing is we're saying, okay, I want to create a circle with a default radius, and I'm going to tell it what the area is of that. So here, what I'm going to do is I'm going to set a breakpoint here. Okay, right there. So I'm going to compile it. Hopefully no errors because I didn't make any changes. Okay. Notice something here that happens. When I compiled this Java file, I got a class file for the test simple circle class. I also got another class file for the simple circle class. So what it basically did was it took this code, compiled it, and created this. Then it took all of this code here, compiled it, and created this thing. Okay. So you can get multiple class files from the same Java file. All right. So if we try to run this, let's see what happens. Let's see. We're gonna do our debug because I want to show you what's going to happen here as I create these things. So if I step in, remember the step in steps into a method. Well, this constructor is a method. Okay, so I can step into it. I can step into this no argument constructor that sets the radius. Notice this has a radius. There is no value for the radius. Well, it's a 0 because there was no value initially. When I step over this, it gives me my new radius value. It sets the radius value. Okay. So I've created my circle. Notice here, I've created circle 1. And it's an object. It's an object in memory. It's an object that have a type. It's an object in memory of this type, a simple circle. Okay. So when I step in here, okay, I'm going to print out the area of the circle of radius, whatever the radius is, and I'm going to get that area. Okay, so when I step in, I'm stepping into the get area method that's going to calculate my area and return that value. Okay, and when I print it, it's going to say the area of a circle with radius 1 is basically pi. So notice now when I can create a circle 2, it's going to do what? It's going to create another variable called circle 2. It's an object. Notice its address is different. It's still a simple circle. Its radius is different from the other one, right? Because I gave it a parameter. I gave it a value here. So if I say what is the area of a circle of radius 25 is whatever this is, 25 times 25 times pi. So let me step in on this one. Let me step in here to show you that. Notice that it doesn't call this method, does it? A constructor with a value, with a parameter, doesn't call the no argument constructor. It calls this constructor instead. And so it sets my radius equal to whatever the new radius I'm passing is. Right. And now when I see what circle 3 is, see, the radius is there what I set it to be. Okay. So the circle of radius 125 is whatever this is. Now one other thing is the way that we have defined this, the radius variable is just like any other variable. We can change it, we can get it, because notice we got it here, right? And we can take it and we can change its value. So watch what happens. Circle 2, its radius is 25. Do this. All right. Notice its memory, its address didn't change. Nothing about the object itself changed in terms of where it's stored in memory. All that changed was the value of one of its attributes. The value of one of its properties changed from 25 to 100. So now the area of a circle of radius 100 is, right, so pi times 10,000. Okay. Let me add something instead here. Let me add one thing. So let's say I want to modify circle 2's radius to be circle 3's radius. So there's two different ways that we could do that. Okay. Or so now, does this do the same thing? Would this and this do the same thing? Would either of these result in an error? No. All right. Many of you are understanding that this does not do. Okay. Many of you are understanding this does not do the same thing. Let's actually this is not right. Instead of doing circle 2 and circle 3, let's do circle 1 and circle 3. Okay. to see what happens, to make it very clear what happens here. And what I'm going to do is I'm going to stop at this line. Here. Okay. So we'll debug. So we're going to get a bunch of areas first. Okay. Now notice the memory locations, the information. So radius 1 on circle 1, radius 100 on circle 2, radius 125 on circle 3. Notice the memory locations 332, 333, 334. Okay, these are because these are going to be important. So if I step over this, if I say, okay, execute this line of code. Notice the memory location didn't change. It's still two separate circles, 333 and 334. It just so happens that now the radius value here is the same as the radius value here. What happened was this was treated like a variable, and it said, give me the value of circle 3's radius. Okay. And then it says take that value and assign it to the variable radius in circle 2. So it's basically just like if we had done, you know, A equals B, and both of them are integers or doubles or whatever, right? It just took the value here and copied it into here. So then in circle 2, its information is there. Now let's see if this does the same thing. Some of you are saying, no, this doesn't do the same thing. It does something different. Okay. Let's see. So we're looking at circle 1. We're looking at circle 3. Step over. Now notice something. Not quite the same, right? These are still the same. All right. But here, the addresses are now the same. It points to the same object in memory. Right. And the reason why this is important is, let me do one more thing and then we'll call it a day since it's 3:20. Okay. The reason why this becomes important is because what happens if we do this second? I'm going to take this and I'm going to put it here. And then I'm going to do the same thing down here, but with circle 1 instead. Okay, you're going to see why this is important here in just a moment. Okay. All right. So circle 2. We gave it the same value as circle 3, and then we changed circle 2's radius, and circle 2's radius changes. That's what we expect to happen, right? That's what we would expect would occur, right? We changed the circle 2 radius value to match that of circle 3. We did something with it. We printed out the get area. Then we said, okay, change circle 2 back to 100. Okay. Circle 1, on the other hand, circle 1 points to the same location, same object as circle 3. So what happens when we change circle 1's radius? It changes both of them. Both circle 1 and circle 3 got changed to be 100 now. And the reason why was because both circle 1 and circle 3 both point to the same object in memory. So if we change one, we change both. Okay. Ismail, yeah, you're asking, so because in the slides, let's see, after here, after this line, yeah. Right, because it would also, this line would also change both of them. Yes. Yes, Omer. Okay, so Ismail, you're asking, because in the slides, what it shows is like this, right? So that's what you're asking is, what's the difference between this and this? What's the difference between this rather and the other way? This right here. Okay. Functionally, neither of those is functionally, those are not different. Functionally, those are the same. There can be some things that we might want to do inside of a no argument constructor, but basically it's two ways of doing the same thing. All right. So you just make it here, you make it here, you give it a default value here, or you set it up in the no argument constructor. Where this can be different is, imagine if we didn't have a no argument constructor, we just wanted to give a default value and have some other constructors, then we could do that using a default value like this. Okay. Lots of different ways. Again, there's lots of different ways to do similar things, and just yeah. Let's see. One other thing. This whole set radius, it's another way to do this whole giving a radius a new value. We will talk in future weeks about what's called accessors and mutators is the fancy word for it, is the big word. I don't expect you to memorize that. I don't expect you to know those words, but getters and setters are what we talk about. We talk about them as getters and setters. Usually what we'll have is for security purposes, is we'll make it to where this variable cannot be used by a parent program, by another program. So like most programs that are well written, a line like this would give an error because this program wouldn't know about this radius variable, because we would want to prevent users from being able to give values like -1. Like, what's a circle with a -1 radius? That doesn't make any sense, right? So we would want to control what values a user could put into our variables. And so what we would do is we would make it to where they could not see this variable directly, but they could get to it through set methods and then get methods to get the value. Okay, so yeah, so get used to set and get as methods for these things. Okay. All right. So, are there any other questions? Good discussion. I think I've caught all the questions. Lots of comments. Okay, I think I got everything. Okay. If there aren't any other questions, good. Or if you do have questions, that's good too. But that's all I wanted to go over for today. I just wanted to kind of give a brief introduction to object-oriented programming and go over a few examples. So if there's nothing else, then what we'll do is we'll call it a day, and I will see you guys in 1 week. Have a good weekend. Have a good afternoon.